Shapelets. We will be creating a very simple data app with a study of churn in bank customers. We will start by adding some imports for the Shapelets modules that we will use here. And in order to create the data app itself, we need to use the following code. So we're going to first call init session, and we're going to pass the username and password that we will use to log into the data app. And we will be calling this data app constructor with a name and a description for our data app. And then for the data app to become usable, we need to register it. And we will be doing it with the method register data app. Okay, so now in here we can add all the contents for our data app. We will start by loading our data. So we will be using pandas for this, and I'm going to add at this point both pandas and NumPy to our list of imports. Okay, so now that we have pandas available, we can read the data, and we'll be doing that using read CSV. And then we will create some markdown text, and we will do that the following way. So right after reading the data, so basically we create this markdown, we fill it with all the text that we want to have in our data app, and we can format this using markdown format, standard markdown format. And then once we've finished the markdown, we simply place it into the app, and then this will make it become visible in the data app. Okay. Now we will be doing in the data app will be to check for missing values and unique values in the data frame that we just loaded. So in order to do that, I'm going to add a couple lines of code. So with this code, we will be checking the columns with missing values. We will create a list of columns and count the number of nones in those columns. And we can plot the missing values in the following way. So we create a figure by calling PLT. So we're using Matplotlib, and I'm going to also add some plotting tools that we will be using at this point. So we will need both Seaborn and Matplotlib. Okay, and now that we have Matplotlib available, we create Matplotlib a pyplot figure, and we store it in this variable. We create the figure using we create the plot using Matplotlib as usual. We're creating a bar chart, and once we've done it, we simply create an image and add the figure to the image. Okay, and then once we have this image, we simply place the image into our app, and this way we make it visible in the data app. Okay. Now, after this, we're going to add another markdown text in order to explain what we've just seen. And now we're going to look for check the number of unique values in each of the columns. Okay, we're doing this using nUnique. And similarly, we can create a bar chart with all the unique values, and we're doing basically the same here. We create a figure, Matplotlib figure, and we create a bar chart. Then we put this figure into an image and then place the image into the data app. We're going to add another markdown text here. Actually, there's more. So it goes all the way to here. There you go. So we've created this markdown and also placed it into the data app. And now we're going to create a chart in order to plot the proportion of churned and retained customers. This is a pie chart, and we're doing it the usual way. So we create the figure and then add the figure to an image and place the image into the data app. Okay. We add another markdown text. And it's here. So another markdown text here. And we are going to now check the relationship between the churning and each of the categorical variables that we have here. So country, gender, whether the customer has a credit card, whether the customer is active, etc. And then we're going to create another markdown text after placing this image in order to, again, explain what we've seen in the previous chart. And we create another chart where we check the relationship between churning and each of the continuous variables. Okay, here we're using box plots in contrast to the count plots that we used for the categorical variables. Okay, now we add one more markdown text where we comment what we've seen in those box plots. And now we're going to go into the training a model, actually training 3 models and evaluating them. So we're going to first drop all the nans and infinite values in the data frame, and we're going to split it into train and test sets. We're going to define the continuous and the categorical variables that we will be using in this study. So here are the continuous variables: credit score, age, tenure, etc. And these are the categorical variables. And we're going to build the data frame that's going to hold all the training data. So basically the labels plus the continuous variables and the categorical variables. For the categorical variables, we're going to use one-hot encodings. And this code will turn these features into one-hot encodings. Okay, so this code will be taking care of that. And also we're going to run a min-max scaling on the continuous variables in order to normalize the ranges. And now we're going to place one markdown where we basically explain what we're going to do next, which is to train 3 models, like I said before, a logistic regression model, a support vector machine with an RBF kernel, and a random forest model. In order to do this, I'm going to add some imports that we're going to need for this. So I'll go all the way up and add first the models that I will use. So I will be using the models from scikit-learn. And I'm also going to add at this point the scoring functions that I will be using, which are ROC AUC score, the ROC curve, and confusion matrix. So now we can go ahead and train the models. So here's the code for training the logistic regression model, and so we basically create the model and call the fit method. We do the same with the SVM, and we do the same with the random forest. We're using a depth of 8 for this random forest classifier. And then we're going to use this function. We're going to define the function get AUC scores in order to compute the scores. So this will give us the AUC score, the false positive rate, and the true positive rate. And we're almost ready to get the scores. We need to define our X and Y for training. And here are our AUC scores. So we're calling our get AUC scores, and we're passing the ground truth, the output of the model, and the probabilities provided by the model. And once we have these AUC scores for the training data, we can plot it. So we're going to create a figure, and we're going to add three lines, one for each of the models, and one more line with basically a random model, which is a straight line. We will see that later when I show you the whole data app. Now for the test data, we're going to be doing the same. So we create the test data frame with the labels plus the continuous variables plus the categorical variables. Again, we turn the categorical variables into one-hot encodings for the test data now. And we're going to ensure that all the one-hot encoded variables that appear in the training data are also here in the test data. Then we're going to run min-max scaling like we did before, but now with the test data. And also we're going to ensure that we have the same order for each of the features in the test data. And now we can compute the AUCs for the test data, and we can plot again a ROC curve for the test data with these results that we just got here. Okay, and this is exactly the same that we did before for the training data. So once we have these results, we can add a markdown to comment on them. We're going to finally compute and plot the confusion matrix for the test data. So we compute the predicted values for the test data, compute the confusion matrix, and then create a figure where we show it as a heat map. And like we always do, we create the figure, add the figure to an image, and place the image into the data app. And we're almost done. We just need to add one more markdown in order to comment the results and conclusion for the whole use case. And now we can just run it. Now it's training the models, running all the code, and it's creating the data app. So now we can simply click here and we can log in with our credentials. So admin, and here's our data app. We click here and here it is. So we have our markdown, bar chart for missing values, bar chart for unique values, the pie chart for the churning customers and retained customers, bar charts for the categorical variables, the box plots for the continuous variables, and here are our rock curves for all three models plus the random model, and the same for the test data. Here is the heat map for the confusion matrix, and this is it. So we have seen how to create this use case study for bank customer churn using Shapelets. Thank you.